In a famous blog by Vitalik Buterin, the co-creator of Ethereum classified ZK rollups into 4 different types based on their level of support of the Ethereum virtual machine. Note that this classification applies only to ZK rollups and not optimistic rollups. The first category of ZK rollups, or Type 1, are those who offer full compatibility with the EVM. This means that every single Solidity smart contract present on Ethereum could be deployed to this type of rollup without making any change. The downside is that the performance of this type of rollup would be so bad that it wouldn't be viable. When we talk about performance, we are really talking about the cost of deriving a validity proof out of a transaction. Some operations that are cheap on the EVM are very expensive on CPUs based on ZK circuits. For this reason, there aren't any projects trying to create this type of system. Type 2 rollups are those who offer a high level of compatibility with the EVM, but introduce small changes to the specification to make it more suitable for ZK circuits. Such changes could be modifications on how internal storage is handled to make it a bit more friendly with the creation of validity proofs, but its performance would still be dismal. Again, no project is attempting to create this type of rollup because of the performance trade-offs. Type 3 rollups introduce even more modifications to the EVM to improve performance, like using different hash functions and precompiles. At this point, it's a balancing act between supporting most Solidity smart contracts out of the box and keeping performance at a reasonable level. Some smart contracts would require changes before being accepted by this type of system, so compatibility is partial. There are plenty of projects pursuing this type of rollup, like ZK-Sync, Scroll, Polygon ZK-EVM, and Kakarot. Kakarot is an interesting project because it uses the CairoVM under the hood, but creates an interpretation layer on top that converts EVM bytecode into CairoVM bytecode. From the point of view of the user and the tools, this is an EVM chain, but internally it takes advantage of the same technology stack as Starknet. You can learn more about this project by visiting kakarot.org. The last category is Type 4 rollups. These types of rollups use a completely different virtual machine that is not compatible with the EVM. They do so in order to create systems that are able to extract the maximum performance out of a computer architecture that's based on zero-knowledge proofs. They are the most efficient when it comes to creating validity proofs and also offer the cheapest transactions. The downside is that developers will need to rewrite Solidity smart contracts into a new programming language that compiles to a different type of system. This is where Starknet lives with the CairoVM and the Cairo programming language, but also a Polygon Meeting that also uses ZK Starks under the hood. Although Aztec technically falls in this category because it uses its own virtual machine, their focus is not on performance, it's on privacy. Creating a system that is able to provide private transactions generates a different set of trade-offs that's out of scope from this course. In short, Starknet made the decision to look beyond the EVM in order to create the most performant system based on ZK Starks at the cost of having to bootstrap its own ecosystem. This bet is already paying off as the Starknet is the cheapest layer 2, even when adding optimistic rollups to the comparison.